Hello everyone, welcome to the next part of the CSES problem set. So the today's question is two knights. Here we are given a number n and we have to find all the positions on a k cross k chessboard where the two knights do not attack each other. So for such kind of problems, we need to make a formula, and then using that formula we can just loop from 1 to n and find all the number of positions where the two knights do not attack each other. So let me first take an example. So for 1 cross 1, there are no such positions since there is only one block where two knights cannot be placed, so the answer will be 0. Now coming to the 2 cross 2 board, if I place a knight k1 here, so the other knight can be placed on three places. Here, this block, and this block. So for each place, here I have total 4 places. So k1 can be placed on 4 places, and for k2 we are always left with 3 places. So here total number of ways will be 12. But here we observe that there are multiple places which are overcounted or recounted again and again. For example, when k1 is here and k2 is here, then when k1 will be here, then k2 will be again here. So that position is counted. So every position is counted twice. So we need to divide this by 2. So we will be left with 6. So the answer for 2 cross 2 chessboard is 6. Now similarly, if for example, let me take a big example now. Let me take 4 cross 4 or 5 cross 5, let us say. Wait, let me draw it. Yeah, 1 2 3 4 5, 1 2 3 4, and one more. Okay. So first of all, I am finding total number of places where I can place knights irrespective they attack each other or not. So that will be, for example, if I have I have k cross k chessboard, so that will be k. Let me find the total. So total squares will be ts. I am writing total squares as ts. Will be k cross k. Total squares are k cross k. So let me also rename it as n. So the total places, total number of positions where I can place knights can be n into n minus 1 by 2. Or you can simply get this formula as nc2. Like out of n choices, I am picking up the two choices to place the knights. So it is n into n minus 1 by 2. So irrespective of their positions, whether they attack each other or not, I have total this much ways to place the knights. Now I will subtract the places where where the knights will attack each other to reach my final answer. So to find the total positions where the total number of positions where the knight will attack each other. For that, let me create an example of again 4 cross 4 this time. Okay. So first I am focusing on vertically downwards direction. We need to focus in this direction only. Okay. So starting from here, if I place a knight, so it can attack in downwards direction only here. For example, let me name the columns 1 2 3 and 4. So if a knight is placed on 1 comma 1, then it will attack the knight placed on 3 comma 2. Okay. And similarly, if a knight is placed on 4 comma 1, so it will attack the knight on 3 comma 3. I hope this much is clear. Now between 1 and 4, if I place knight anywhere on 1 comma 2 or 1 comma 3, they will always have two positions to attack. Okay. For example, if I place knight on 1 comma 2, so it will have two positions to attack. Those are 3 comma 1 and 3 comma 3. Similarly, on 1 comma 3, there are two positions to attack for the knight. One is 3 comma 2 and other one is 3 comma 4. So if I have a k cross k long chessboard, for example, this dimension is k. So out of two positions, every other position has two options. So leaving the first one and the last one. So I will add these positions separately, and the rest k minus 2 positions. I'm just now talking about the first row. only about the first row. Okay, so every other position in the first row will be having two options. So I get this formula for only one row. Okay, now how many now I am talking about only the vertical direction. So what is the last row in which the knight will be able to attack vertically downwards? So from second row on onwards, the knight is able to reach the fourth row, and from third row the knight won't be able to attack in the downward direction. Okay, so this means if I have k rows vertically down, so that means knights will be able to attack only till k minus only from k minus 2 rows from the bottom. So if I go from for example here the 4 cross 4 matrix was taken. So 4 minus 2, therefore from the second row onwards, this is the last row from where the knight can attack. It cannot attack vertically downwards from the third row onwards. Okay, so that means total number of vertical attacks which I get from this row to all the rows will be 2 plus k minus 2 times 2. These are the number of attacks in one row, and total number of rows are k minus 2. I hope till here I am clear. Now you must be wondering what about the attacks, like for example let me draw it again. 1 2 3 and 4, yeah. So you must be wondering what about till, since we counted till here. Wait, let me make it 5 plus 5. Yeah. So since these are 5 rows, so the last row from which knight will attack is third row. So here the most common doubt is what about the fourth row and the fifth rows? What about them? And what about vertically upwards attack? So they are already counted. Since we are counting from the third row, so this knight is attacking at this position. But the other way we can see this as this position is also attacking this position. Okay, so that way these are already counted. For example, we don't need to check it vertically above in vertically above direction, because if we count those, then it will double count the number of positions, and that will lead to wrong answer. So every position is counted in the vertical direction. Now about the horizontal direction, it's the same case. For example, if a knight is placed here, then it will attack in this block only, and if a knight is placed here, then it can attack in this block only. The rest k minus 2 positions will have again two options to attack, here and here. So let me now write it down. So earlier we were having a total number of vertical attacks as 2 plus k minus 2 times 2, and this was for a single row, and total number of rows we were having were k minus 2. Now this is what we figure out for vertical rows, and for horizontal we have the similar formula coming up. So we need this two times. So if we simplify this, let me make it large. Yeah, so I hope now this is visible. So let's solve this. So this will be 2 plus 2k minus 4, and this becomes k minus 2 times 2. Now this becomes 2k minus 2 and k minus 2 star 2, and if we take 2 common, then it will become 2 star k minus 1 k minus 2 star 2, and if we multiply these two, so we get 4 star k minus 1 star k minus 2. So these are the total number of positions on a k cross k chessboard where the knights will attack each other. So we will subtract these positions from the total available positions. So if I am taking n as k cross k, which are the total number of blocks on a k cross k boards. So total available positions were n into n minus 1 by 2, and therefore our final answer will be, we will subtract this 4 star k minus 1 k minus 2 from total available positions. So this is our final answer. This will be our final answer. It will give us the places where the knights will not attack each other on a k cross k chessboard. So let's code it up. I hope it's clear till now. If you have any doubts, you can ask me in the comment section. So okay, so we will be given an input n, and let me take c in n. So int, let me take it as k. Okay, that won't lead to confusions. So int n will be k cross k. That this is the total squares on the k cross k board. So I will be finding the total available positions. So that is n into n minus 1 by 2, or you can say simply say nc2. So these are the total positions where I can keep the knights irrespective they attack each other or not. Okay, like these are the total number of positions where I can keep them. And int attack positions are 4 star k minus 1 star k minus 2. So these are the attacking positions, number of positions where the knights will attack each other. Number of positions where the knights will attack each other on a k cross k chessboard. Okay, so now we are given n, and from 1 to n we need to print the ways. For example, 8 is given, so for 1 cross 1, 2 cross 2 till 8 cross 8 we need to print the ways. So I will just loop for int I is equals to 1, I less than equals to k, I plus plus, and we'll put everything inside it. Okay, so let me change the variables, and this will be n only, and I will put everything inside control X. Okay, let me rename this as n. So, and our final answer will be C out total available positions minus attack positions. So this will give me the total number of safe positions. Let's check the for a test case 8 and see if it's working fine or not. So we are getting 0, 6, 28, 96, 252, 550, 1056, 1848. So you can see we are getting the correct output. Let's submit it. So at one place I got wrong answer. Okay, so that must be because of the long, since everywhere I'm taking the large values, so I must use long. That must be surpassing the integer limit. Let me resubmit it. Yeah, it got accepted. So one other way I would like to discuss for these type of questions is that, see, for each and every time an input is given. So from, for example, input is n, let us say n. So for 1 to n, every time I'm calculating 1 cross 1, 2 cross 2, 3 cross 3, 4 cross 4 for every test case. Okay. So what I can do is I can take the maximum limit for, I know the maximum limit for n is 10 to the power 5. Sorry, 10 to the power 4. So I will just pre-compute it outside this only solve function. Let me show how. So for int k is equals to 1, k less than equals to 10,000, and k plus plus. So I will just store it. So int answer 10,001. I will just declare it for the size 10,001 and initialize it everything with 0. And after that, I will just copy paste everything. Control C, Control V, Control X, Control V, and for the sake of just I want to make it perfectly in line. Okay, and now what I can do is instead of cout, I will just simply store answer of I as attack pos total available position minus attack position. Sorry, answer of k, since we are using the variable name as k. Okay, and it will. Now what we have done is we have pre-computed for all the values, and now whatever input will be given, so we can just cout a of k, and sorry, answer of k. So it must be 8 here. Yeah, and it must be, for example, if I want for 13. Yeah, so these things are fast when we have multiple test cases, but here, since we are only having a single test case, so that doesn't make much difference. If I submit it, it will work. Oh, I think again I forgot to change here for. Okay, so I declared the integer. It should be long, long. So now it should work. Yeah, it got accepted. Okay, guys, so that's it for today. Thank you.